All right, so now we are into chapter 8, and chapter 8 is similar to chapter 7 in that what we're going to do is we're going to take sample data and then we're going to say, this is what my sample data says, therefore this is what I think about the population. And that's what a statistical hypothesis is. We have a conjecture, which is just a fancy name for an educated guess about a parameter. If you remember, a parameter is a population measure. So what we're going to always talk about is mu, the population mean. You can do this same stuff for other things, population standard deviation, population variance, so on and so forth, but we are only going to do mu. Okay, so it's a conjecture about the population mean based on a statistic, which is our sample mean. So X bar. So what we're going to do is we're going to say, here's what our sample data is, therefore this is what I think about the population mean. So in chapter 7, what we did is we said, based on our sample, we think the population mean is between this number and this number. What we're going to do now is we're going to say that the mean is greater than or less than, or maybe just not equal to, or maybe it really is equal to a certain number. Okay, in chapter 8, we're going to say that the mean is equal to, not equal to, greater than, less than a certain number. All right, so 8.1 is just all about this is how you set the problems up. We're not going to put any actual data with it right now, so it's not really going to make sense. But hopefully once we get to 8.2, it'll make a little bit more sense. All right, in every statistical hypothesis, you have to have a null hypothesis and an alternative hypothesis. The null hypothesis is written as H sub 0. All right, H sub 0. What this is this is a hypothesis that states the mean is equal to a given number, or that two means are equal to each other. And that part will be in chapter 9, those two things. This one is in chapter 8. So chapter 8, we're going to compare the mean to a certain number, a given number, and in chapter 9, we're going to compare two means to each other. So first we make a null hypothesis, and then we make an alternative hypothesis. This one is called H sub 1. So H sub 0 is your null hypothesis. H sub 1 is your alternative hypothesis. This is a hypothesis that states the mean is different than a given number. So again, that's what we're going to do here in chapter 8, or that two means are not the same. And that's in chapter 9. Now, this is going to be where we have to do not equal to, greater than, or less than, and it will depend on what the question is asking you, like you'll see once we get further on. All right, so H sub 0 is always an equal sign. H sub 1 is going to be a not equal to, a greater than, or a less than. All right, so what chapter 8 and chapter 9 is all of them are 5-step problems. Okay, so there are going to be 5 steps that we have to do for all these, except for in chapter 9, we're going to add some confidence intervals back in. But in chapter 8, every single problem we do is going to be 5 steps. Okay, so the hypothesis is step 1 out of 5. And again, in 8.2, you're going to get all the steps together, so it will make a lot more sense then. But we just have to get through what each step kind of looks like here. Okay, so this is going to be step 1. For a two-tailed test, and again, that doesn't make sense right now, but usually I go back and forth on notes, but we'll just do this all. A two-tailed test says this. H sub 0 is that mu is equal to k, which again, k is a given number. So we might say that the mean is equal to 10 or 17 or whatever it might be. All right, then your H sub 1 is that mu is not equal to k. All right, so we don't care if it's greater than or less than, we just want it to be different than. Okay, so this will look like this. Step 1, H sub 0 is that mu is equal to whatever number they give us. H sub 1 is that it's not equal to. For a right-tailed test, here's the nice part. H sub 0 is always equal to. That's what it says up above, equal to. So that part's not going to change. H sub 1, if we want it to be to the right, that means we want it to be greater than whatever number we're given. All right, and then our third one is the left-tailed test. Hopefully you can figure out what that's going to look like. H sub 0 is still that mu is equal to k, whatever our given number is. Since we want it to the left, that means we mean less than k. Okay, so step 1 is going to look like one of these three options. Okay, the only difference is you're going to have a number in there for k, and notice it has to be the same number. Okay, so the H sub 0 will be mu equals that number. H sub 1 will be either greater than, less than, or not equal to based on what it's asking us. All right, and that's what we're going to practice first. So again, all we're going to do is do H sub 0 and H sub 1. So a researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6. That's what it is right now. So H sub 0 is mu equals 8.6. Right? Because that's what it is right now. H sub 1, we see this word increase, so we think it's going to be greater than 8.6. So again, if you're going to be a researcher, what you do is you have to come up with a conjecture first, and then you test it. Just like you do for a science experiment. You make a hypothesis, and then you do the experiment. All right, so that's what this is, only just in mathematics. So again, H sub 0, right now the mean is 8.6. This researcher thinks if we give vitamins, it's going to be greater than 8.6. All right, one thing it doesn't tell us to do, but we need to practice, is we have to decide which one's the claim. Okay, and it says the researcher thinks it will increase, so their claim is the greater than. Number 2, an engineer hypothesizes that the mean number of defects can be decreased in a manufacturing process of CDs by using robots instead of humans for certain tasks. The mean number of defective discs per 1,000 is 18. So again, H sub 0, mu equals whatever the mean is right now, which is 18. H sub 1, the researcher thinks we can decrease. So less than 18, and that one would be his claim because that's what he thinks he can do. Number 3, a psychologist feels that playing soft music during the test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was 73. So H sub 0, the mean right now, what we know is 73. Alternative H sub 1, not equal to 73. We don't know what it is. Says the researcher doesn't know if it's higher or lower, just different. So again, that's going to be the claim. You'll see when we go through this, more than likely H sub 1 is going to be your claim, unless it explicitly says, like if this one says, the researcher thinks the birth weight will still be 8.6, then you're going to have an equal sign. But again, we'll do some so that it makes sense where that comes in. All right, so what we have to do is once we make a claim, we have to test that claim. So we have to run a statistical test. This is either going to be a z-test, which is 8.2, or t-test. So this will tell us when we need to use which chart, z-test, z-chart, or t-chart. You use sample data. to make a decision whether or not to reject the null hypothesis. Okay, and so again, once we do this with an actual problem, hopefully it'll make more sense, but that's what it's going to be. All right, the test value is your t-score or your z-score. Obtained from your sample data. So you'll do your normal z or t calculation to figure out what your test value is. Okay, this next page we're going to not do much with, but those of you that like Punnett squares will like this. So there's 4 things that can happen. So your null hypothesis is either true or it's false. And honestly, we don't know because it's about your population mean and we don't know what the population mean is. We know what the sample mean is, okay? So we don't know whether it's true or false for real. We just have to do our best guess, basically. All right, and then you're either going to reject your null hypothesis or you are going to not reject. So the best way to think about this is a jury trial. In a jury trial, you're either innocent or guilty, but the jury can either convict or not convict you. Okay, so sometimes they're wrong, unfortunately. So if it's true, but we reject it, that is a bad thing. That would be a mistake. All right, if we reject it and it's true, that would actually be a mistake. If it's false and we reject it, that's a good thing. Okay. If it's true and we don't reject it, that's also a good thing. And then if it's false but we don't reject it, that's also a bad thing. Okay. This one right here is called a type 1 error. And this is a type 2 error. Not super important that you know those, but this one right here is one that we are going to account for. We can't, unfortunately, account for these. Okay, and where that level significance comes in, that's here. Okay, this is your alpha, just like we used in chapter 7. Okay, it's your alpha. So you choose this in advance. This is the probability of making a type 1 error. All right, so again, this will be chosen in advance, just like it said 95%. You'll see this is very similar. 95% confidence interval, it's going to say alpha equals 0.05 or a 0.05 level of significance. So it's going to be given to you ahead of time. And then we'll use that in our chart to figure out what it is, okay? But what it is, it's your probability of making a type 1 error, where the null hypothesis is true, but our numbers tell us to reject it anyway. We can still do this, okay? But we don't have a mathematical way to calculate that.